Chapter 5, Part 2. And really the basis for Chapter 5, Part 2 is what happens if our diamond doesn't work, right? What happens if we fill up the numbers, the A times C on the top, the B on the bottom, we put our numbers on the sides, but what happens if it just doesn't work for us? What do we do? So we have to have some different ways to go about that, and there's several different ways that you can do this. One of them they talk about in section 521, and it's known as a perfect squares. This is going to be the least popular way that we're ever going to solve these. So we're just going to kind of skip through and show it to you, but not really spend a lot of time on it. But if you ignore this way, because this way only works if it turns out to be the same thing twice, and it's a real specific example, we're really looking at three different ways. One is we use the diamond, but really it's just sort of factoring. Other people might use sort of like FOIL or guess and check or whatever, but same thing really. There's something called completing the square, which obviously will show up in 522 and 523, but we're going to skip them. But you can use completing the square to get your x-intercepts. We're actually going to use completing the square later in Chapter 9 to help us find the vertex. So we'll use completing the square for that. And the third way is known as the quadratic formula. Quadratic formula. Okay, so again, all three of these ways can be used to get the x-intercepts, but we're not going to use this. What we just kind of decided as a math department was that if the diamond doesn't work, the quadratic formula always works. So the diamond works sometimes, completing the square always works, but sometimes it's a real pain to do. And quadratic formula always works, and usually it's easier than completing the square anyway. So we're kind of like, why bother with completing the square to find x-intercepts? We're going to show you completing the square later to get the vertex. Maybe I'll show you how to get the x-intercepts completing the square as well. But we just kind of wanted to let you know, I guess, in a sense, what you'll be missing. So let me pause and clean this up and then keep going on this video. 521 introduces a method that is rarely used to solve the x-intercepts. And don't forget, we're still talking about different ways to get the x-intercept, right? If the diamond doesn't work, what other options do we have? And this is one of them. If it turns out that you have the same thing squared, you can just square root it. But you can see how specific this is. First of all, you have to have the same thing twice, and a square root and a square undo each other. So just like adding and subtracting undo each other, a square root and a square undo each other. And then over here, I would have to have a perfect square to make this easy at least. So 7 times 7 is 49. But don't forget that we can also get -7, right? -7 times -7 is also 49. So this is kind of a nice way to solve these things, but you really have to sort of recognize exactly what you're looking at, and you have to recognize that it's going to work out easily. So this is pretty rare that you're going to get something that will work like this. And by the way, if you do get something that looks like this, it would have worked if you used your diamond here and did your 2x minus 3 and your 2x minus 3 and turned it into standard form. The diamond would have worked anyway. So it's just one way to do it, but it shows up really rarely. But here we would have our x-intercepts at 5 and at -2. And again, if we had used an area model to put it in standard form, we could have then used the diamond and we would have got the same x-intercepts at 5 and -2. All right, 522 and 523 is completing the square. And like I said at the beginning of the video, we're not going to use completing the square to get the x-intercepts, although you can. But completing the square essentially looks like this. Like if I have if I have x squared plus 4x plus 1, if you think of algebra tiles, there's x squared plus 4x plus 1, right? If I add 3 to both sides, if I add 3 more blocks over here, I'll get a perfect square. And then I can use that logic to sort of do what we just kind of did up here, right? So that's kind of the strategy that we're skipping. Again, it is the thing. We just decided as a department that it's kind of a pain to teach, and it doesn't always work out evenly. It doesn't always work easily, so we skip it and go straight to the quadratic formula, which we will talk about next. A whole point that we're doing here is we are talking about different methods to get our x-intercepts if the diamond doesn't work. And what we said, completing the square, we're not in love with that. So the quadratic formula always works. And let's go ahead and jump into that. Again, it's just a way to do this. So it says consider x squared minus 3x minus 7. Let's go ahead and use the diamond to solve it. So if I'm going to put negative 7 up here and negative 3 up here, and you can see I need numbers that multiply to 7 but add to 3. Well, that's going to add to 6 or 8. And now 2 doesn't go in and 3 doesn't go in. So the diamond doesn't work. So I got a problem. So what do I do when the diamond doesn't work? And introduce the quadratic formula. And you are going to want to know this quadratic formula. I definitely put it in the note page for you. So don't forget, when we're in standard form, we have y equals ax squared plus bx plus c. So that's what these a's, b's, and c's are talking about. They're telling us to go ahead and take what we have here as far as the numbers and throw them into the quadratic formula. So if I go back up to this original problem here, this x squared minus 3x minus 7, you can see they're going with us still on that. And it is saying, I didn't realize it was so big there. It says when the quadratic equation is written in standard form, that is, it looks like ax squared plus bx plus c. A is the coefficient of x squared, b is the coefficient of x, and c is the constant. We should know that. So here our a is 1, our b is negative 3, and our c is negative 7. So hopefully we know that. It says the quadratic formula calculates two possible answers by using the plus or minus symbol. So we have like a plus and a minus. You can see there's a plus and a minus. So don't forget, you know, it's not a shock. We have two solutions often, right? Sometimes we have none, and sometimes we have exactly one. But normally we have two solutions. So we have that plus or minus there. So we're just simply going to substitute the 1, negative 3, and negative 7 into this equation and solve. So let me set this up and solve that. We're going to say x equals negative b. Well, think about it. It's a negative 3, so that's going to end up being positive. But I still like to just sort of go in order. Plus or minus the square root of b squared is going to be negative 3 squared minus 4 times a is 1 times c is negative 7. And all of it's going to be over 2 times 1. Now I know this looks way worse than it. It looks bad, but it's really not that bad. So again, we'll just sort of solve. So a negative is a positive. So it's 3 plus or minus the square root. Negative 3 squared is 9. I personally like to do the negative times a positive is a negative times a negative is a positive. So I know that if I have like an even number of negative signs, it'll be positive. If I have an odd number of negative signs, it'll be negative. Well, there we go. Like a negative times positive is negative times a negative is a positive. So it's going to be plus 4 times 1 is 4 times 7 is 28. And again, that's just my personal preference, is I like to do the signs first, and then I like to do the numbers second. All this is going to be over 2. Don't forget your plus or minus. So I'm going to get 3 plus or minus the square root of 9 plus 28 is 37 over 2. And the square root of 37 is a little bit more than 6, right? So if I take the square root of 37, I'm going to get 6.08. So 3 plus, this is where I like to break them off in positive and negative now, by the way. 6 plus 6.08 divided by 2, and 3 minus 6.08 divided by 2. So this will give me 9.08 divided by 2, which is, I believe, 4.54. Or, here I get negative 3.08 divided by 2, which I believe is negative 1.54. I'm not necessarily sold on these, so hopefully I'm right. I'm going to pause and go into Desmos, and we'll see if those indeed are our x-intercepts. Y equals x squared minus 2x minus 7, and you can see we did get negative 1.54 and 4.54. So what that means is, think about what this means. That means that if we were using the diamond, that when we set this up, and we had right, negative 7 on top and negative 3 on bottom, and we put 1x on the side, that means we would have had to have picked, again, it's the opposite. I would have had to have picked negative 4.54 and positive 1.54. right? Negative 4.54 times positive 1.54 is about negative 7, and negative 4.54 plus 1.54 is about negative 3. So who is ever going to guess those numbers, right? I don't think many of us were going to guess those numbers. And that's what makes the quadratic formula so powerful, is it always works. So we try the diamond. If the diamond doesn't work, we can do the quadratic formula. As a matter of fact, if you don't want to do the diamond, you can go straight to the quadratic formula, because this always works. All right, let me keep going here. Just practicing the quadratic formula, and again, don't forget it's y equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. I would strongly encourage you guys to have that note page handy with this on it. All right, so here I'm going to do a. My a is 3, my b is 7, my c is 2. So I will get negative 7 plus or minus b squared, which is 7 squared, minus 4 times a is 3. By the way, I always like to drop these in parentheses just so I don't screw up my signs here. 4ac, all of that is over 2a. So I'm going to get negative 7 plus or minus the square root of 49 minus 24 over 6. So I will get, by the way, this is a. I will get negative 7 plus or minus the square root of 25 over 6. So I will get negative 7 plus 5 over 6. And I will get negative 7 minus 5 over 6. So I get 12 over 6, which is 2. Or I get negative, I'm sorry, that's 2. Negative 7 plus 5 is negative 2 over 6, which is negative 1/3. Or I get negative 12 over 6, which is negative 2. So I expect these to be my two x-intercepts. I'll set this up and see. 2 and negative 1/3. Just like we thought, I will go ahead and set up b. A is 2, my b is negative 9, and my c is negative 35. So I'll go up here. I have a negative 9 plus or minus the square root of negative 9 squared minus 4 times 2 times negative 35. All of that is over 2 times 2. So I will get 9 plus or minus the square root of, this is going to be 81. Negative, positive, negative, so plus. And this will be, you can go out of order. I'll say 70 times 4 is 280 over 4. So I will kind of go up here. I get y equals 9 plus or minus the square root of 361 over 4. I do not know what the square root of 361 is. So the square root of 361 is 19. I had no idea. So y equals 9 plus or minus 19 over 4. So I'll get 9 plus 19 over 4 is 28 over 4, which is of course 7. And I will get 9 minus 19 over 4, which is negative 10 over 4, which is negative 5/2. And again, we'll run over to Desmos and make sure that our x-intercepts are 7 and negative 5/2. X-intercepts at negative 2.5 and 7. And again, don't forget, that means that on the sides of the diamonds, those are the numbers. We would have had to guess positive 2.5 and negative 7 to get that to work. So not super likely we would have picked those numbers. All right, let's go ahead and set up C. A is 8, B is 10, C is 3. So I will say y equals negative 10 plus or minus the square root of 10 squared minus 4 times 8 times 3 over 2 times 8. So I will get negative 10 plus or minus the square root. 10 squared is 100 minus, here 32, so minus 96. All of that is over 16. So if I go up here, I'm going to get y equals negative 10 plus or minus the square root of 4 over 16. So I get negative 10 plus 2. The square root of 4 is 2, right? So I get negative 8 over 16 is negative 1/2. And over here, I'm going to get negative 10 minus 2 over 16. I'll get negative 12 over 16, which is negative 3/4. And again, I'll go over to Desmos and make sure I get negative 1/2 and negative 3/4. Alrighty, so there we go. We do have the correct one. So again, you can see just super convenient to have this quadratic formula for the ones that don't factor, right? The odds of us guessing positive 1/2 and positive 3/4 are pretty low. Okay, let's go ahead and finish up with this last one. A is 1, B is negative 5, C is 9. So I'm going to say a negative negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 9, all of that over 2 times 1. So a negative negative 5. And again, you can see I'm real methodical every time. That way I don't screw up my signs. It's really easy to get your signs screwed up. Negative 5 is 25. A negative times a positive is negative. 4 times 1 times 4 is 16. All of that is over 2. So I'm going to end up with y equals 5 plus or minus, that's going to be the square root of 9, right? Which is obviously going to be 3. So I get 5 plus 3 over 2, which is obviously 8 over 2, which is 4. Over here I'm going to get 5 minus 3 over 2, which is 2 over 2, which is 1, which tells us we probably could have done the diamond pretty easily on this one, right? 9 and negative 5. I hope you guys see what I'm saying here. Just because this worked out so evenly with the 4 and 1, I guess a negative 4 and a negative 1 would work here. And you can see that they do not. So what did I screw up? I screwed up somewhere. Let me pause and find my error. This looked like a 4, but it was a 9. Ugh. So that should be minus 36. So I'm actually going to get this to equal, this is going to be kind of a pain. So I'm actually going to end up with minus 11, right? So y, get rid of all this. So y equals 5 plus or minus the square root of negative 11 over 2. Well, we don't know how to take the square root of a negative yet, right? That doesn't really work out for us yet. So we are going to learn something about imaginary numbers later in this chapter, but for now we don't know them. So let me pause and go ahead and throw this one. Sorry for my error, by the way, but let me throw this one in and let's see where we're at. You can see what's going on here. There is no x-intercepts. And that's what happens, and we're going to learn more about this as the chapter goes, but that's what happens when you get the square root of a negative. There are no what is known as real x-intercepts. There's no real solutions, but there are actually, people invented imaginary numbers, which we'll talk about later in the chapter. So there are solutions. They're just not real solutions. They end up being imaginary solutions. So again, kind of weird, but if you end up with a square root of a negative up here, that just tells you it is not going to cross the x-axis at all. So again, sorry for my mistake, but kind of interesting. Anyway, the problem ends with a couple. The lesson ends with a couple of problems that we're not going to do because it has to do with completing a square, so we're going to kind of skip these. This video felt like it took a long time. Sorry, you have to watch a long one.